Wireless Equivalent Privacy (WEP) originated in 1999 as a means of providing a degree of confidentiality to 802.11. Multiple flaws were quickly discovered in its implementation of cryptography, and by 2004 it was replaced by the Wi-Fi Protected Access WPA protocol. One of the primary flaws of WEP was first identified in the reuse of the initialization vector IV. WEP relies on the RC4 encryption algorithm, which is a stream cipher. The same encryption key cannot be repeated in this cipher. IVs were introduced to guard against key reuse by introducing an element of randomness into the encrypted data. Unfortunately, the 24-bit IV is too short to prevent repetition. In practice, most WEP keys can be recovered or cracked within 3 minutes. To make WEP cracking work, you will also need to know the following information about the target. First, you need to identify the name of the wireless network ESSID. Then, try to identify the MAC address of the access point, the BSSID. And you need to know the wireless channel being used. And finally, write down the MAC address of the wireless client. Let's begin. In this demo, I am using PuTTY to connect to a remote laptop that contains a wireless adapter. And I am using SSH for the connection. Let's start a WEP attack against my own wireless router. First, we need to identify the available wireless network interfaces. Airmon NG will do the job. Here we can see the monitor interface that I created in the previous demo of this module. So what to do next? We will use dump command to locate the target wireless network. And we are going to pick the monitor interface for this command. When dump locates the target, press Ctrl C to stop the search. Copy the MAC address in the BSSID and note the channel. In our example, the target network GAS router is operating on channel 6. Open another terminal window to start dump ng to sniff wireless traffic and collect IVs using the following command. Now paste the BSSID value that you copied from the previous window. The -C argument indicates the channel, and -W argument allows us to write the name of the output file. Now we have to increase the number of transmitted IVs packets. Open another terminal window. Do not close this one. And enter the following command to fake an authentication to the targeted wireless access point. Here, the -1 signals a fake authentication, and the number 0 is the reassociation timing in seconds. At this moment, I need the MAC address of the attacker's machine. So let's check it out. Open a new session. The ifconfig command will do the job. Copy it and paste it in here. The ignore -1 argument ignores the -1 channel of monitor 0. Association successful. Good job. With the fake authentication in place, we will generate traffic that appears to come from a trusted MAC address and routed to the target wireless access point. Again, we will use the airplay ng command to get the job done. This attack is known as an ARP injection or ARP replay attack. Normally, the target access point will rebroadcast the ARP packets. Add another quick command to feed the necessary IVs. Let's open another window and generate some additional packets while the ARP injection continues. Start an interactive packet replay attack by entering the following command. Here, -2 indicates that we are using the interactive replay attack. -P0841 sets the frame control field of the packet to make it appear as if it is being sent from a wireless client. The -C argument, followed by all the F's, sets the destination to send the packets to all the hosts on the network. The -B option, which you should have known, the -B is the MAC address of the BSSID, and the -H is the MAC address of the attacker's machine. Let's go back to the sniffing window and see what's going on. At this moment, you should wait until the data field value is above 5000. Let's stop everything after enough packets that have been collected and saved. More than 20,000 packet is good enough for me. In a fresh new window, I will execute the following aircrack-ng command, which can be used to crack the WEP key. The -A argument followed by the number 1 forces the attack mode to be static WEP. The -B option is the BSSID, and the WEP log 01 is the capture file containing the captured IVs. Check this out, folks. Key found and decrypted successfully.